Let's look at some more examples of conditional probability. So here we're going to be working with a table of values, and this is actually called a contingency table. The probability of one event may be contingent or related to the probability of another event. We are relating majors here and careers that are chosen. We want to determine requested probabilities. Over here is our major. So we had biology majors, chem majors, pre-med majors, had pharmacists, PAs, and MDs as the careers that were pursued out of those majors. So the row total here, for example, is saying we had 30 biology majors, 12 became pharmacists, 13 PAs, and 5 MDs. Chemistry, we had 16 chem majors, 8 pharmacists, 5 PAs, 3 MDs, etc. Column totals here, 33 pharmacists total, 12 were bio majors, 8 chemistry, and 13 pre-med. And then a total of 97, so grand total of everyone that we surveyed. So we want to know what is the probability the person is a PA we know they were a biology major. So that's asking what is the probability the person is a PA given they were a bio major. So PA given bio. Well, first of all, this is an equally likely sample space. It would be equally likely that we select anyone by random there. So we can just use raw numbers here. So remember that definition of conditional probability, you do the number in the intersection in the numerator. So PA and bio, and then divide by the number in the given event. So the given here determines your denominator, number of bio majors. So number of bio majors here, that row total 30. And then out of those 30 bio majors, we want to know how many became PAs, 13. So that 13 is in the PA column and the biology row. That's the number that were biology and became PAs. So that's what we call a joint probability or an AND probability. So you don't have to write the symbolism, but if it helps you, go ahead. What's the probability the person is pre-med given that? So that's another conditional probability given they're a PA. So this is probability of pre-med given they're a PA. So I'm not going to write the formula this time. It's desired out of total. PAs determine the denominator. So PAs, we had a total of 30. And we want to know out of those 30, how many were pre-med majors. So pre-med majors are in this last row, 12 out of the 30. So we're only considering things in that column. 12 were pre-med. Let's look at another one. Probability the person is an MD if we know, that's a conditional probability, they're not biology major. So probability that they became an MD given that they're not bio. So again, the given condition determines the denominator. So the bio majors were 30. So if they're not bio, they have to be in these two rows, 16 and 51. So that's our denominator, 16 plus 51. And then out of these two rows, we want to know how many became MDs. Well, that's these guys here, 3 plus 26. Those are the MDs that are in the last two rows. So desired out of the restricted total, but still desired out of total. So this is 29 out of, 67? And we'll just leave those as fractions. We could change to percentages, but fractions are good too.